Wow. I probably shouldn't have hit record when I was ready to cough. Welcome to 6.3 log and log functions. Um, Logs come from exponential type stuff where we don't really know the exponent. So that's why we did exponential stuff in 6.1, and now in 6.3, we introduced this brand new thing called logs. So it's generally when we don't know this, we can switch it to a log form, a logarithm form, and now we have all of this equals the thing we're missing, and we should be able to calculate this, which we will later. It's very similar to switching back and forth between the fraction exponent and the radical, but we can just switch back and forth between log form and exponent form, and that's a good chunk of what we're going to do today, actually. So switching from log form to exponent form, it's base to the y power equals x. So 2 to the third equals 8. Base to the y power equals x. Base to the y power equals x. And if you remember, negative exponents come from getting moved from the opposite side of the fraction bar. This comes up to the top, and this positive 4 becomes negative 4. So that's why this and this look about the same, because this is just 4 to the 4th power. If we have exponent form, we can always switch back to log form. Whether we have crazy numbers or even with fractions, log base 4 of 2 is 1/2. We can deal with that, working backwards. Really, we should at this point be able to go either way. And you have this from like that first slide. This will be on the board during the test, so you don't have to memorize it. Well, all right, let me do this. Perhaps it's not quite as intimidating. Let me walk you through this, even though you saw it all already, and you may have been like, oh, let me write all this down. Okay, so we can agree 3 squared equals 3 squared, right? Okay, so if I have 3 to the x equals 3 squared, well, x has to be 2 because they have to match, right? So here's the rule. If your bases are the same, then they don't matter. So I could have 3 to the x and 3 squared, and I could just basically drop the bases completely. And it doesn't even matter what the base is. If the bases are the same, then I could drop them. Now, if I have 3 to the x equals like 5 squared, well, we're going to learn about this later. But it can be solved. It's just not the same. You can't just go, oh, well, let me just drop that and x equals 2. Well, no, because 3 squared is 9, 5 squared is 25. They don't equal the same thing. If we have something like this, 9 to the x equals 3 to the 4th. Well, it's not quite what we have over here, because even though they are different, 9 can actually be rewritten to where you have a 3 as a base and some sort of exponent. We can write it as 3 squared, and now all of a sudden they both say giant 3. If you remember these stacked exponents, because we're going to have double exponent here, because 3 squared is 9, and then we still have the exponent of x. These just multiply to become 2x, and now I have 3 to the 2x equals 3 to the 4th. Bases don't matter. Set those equal to each other, do a little bit of solving, just like that. So part of your homework is going to be switching it from one to the other. The other part's going to look basically like this right here, where you'll have to change one, or maybe both of them. You'll have to change one of them to where they both have the same big number. So let's do a little bit of practice. They're actually going to have you do a little bit of both, where you're going to start off and it's just going to say evaluate this. Well, we're going to start by setting it equal to x, switching it to exponent form. Okay, so we switch from log form to exponent form, and then we can rewrite one of these to make them both say 4. And I had some students who were like, hey, can't I just make that 2 to the 4th? Okay, but we'll have to make that 2 squared. So this is totally fine. If you want to do that, if you're like, I know they can both have a base of 2, because we do have this invisible 1 right here. So if we can get this to say 4, like we do here, 4 squared, 2 times x is 2x, 2x equals 1, or 4x equals 2, we're going to get the same answer no matter what. So whichever direction you want to go, it's okay, as long as you don't make any mathematical errors. All right, let's try this one. Log base 2 of 1 over 32. Well, we switched it around. Now, when we have fractions, we look just at this bottom number and see if it can be rewritten. And here's a hint. These numbers kind of have to match, don't they? This one and this one. So see if this can divide into 32 and see how many you got. 2 to the 5th. And let me get rid of those so it doesn't cause an issue. Then we can move it up to the top, give it a negative exponent, finish solving. Same kind of thing here, where we have 4 and 64. Again, both of these can be written as 2 if you really wanted to, but you can absolutely use 4 here as well. I know I told you when we factor, don't use anything other than prime numbers. This is the only time I'm okay with you doing this because I need only the same number. If we did it with 2, then we'd have 2 to the 2x equals 4 to the 6th, and when we divide, we get the same thing anyway. All right, same thing here. This one's a little bit tricky though. When we switch around, we have this. Let me do this. Okay, so the way I like to do it is I like to distribute this x to both of these, right? But 1 to whatever power, this exponent right here doesn't matter. So we really only have 1 divided by 5 to the x. It really only needs to go to the bottom, okay? Then to get rid of the fraction part, we can bring this guy up to the top and give it a negative exponent, right? Or if we're here already, we could bring it up to the top, give it a negative exponent like this. So these are kind of different. And there's really no wrong answer. You're going to end up with 5 to the negative x equals 5 to the 3rd. Technically, it looks like we could say, well, forget doing it that way. Why don't we just put this guy on the bottom of the fraction, and it does work. It does technically work to where x still equals -3. Mathematically, it's a little more complicated than that, but it does work. If you can get the big numbers to be the same, I'm honestly okay with it. Trying this one, 36 to that's 6 squared. I mean, you can get a fraction answer, not a big deal. And there's your homework for 6-3.